So section 3.2 is angles formed by parallel lines and transversals. So this is a warm-up, and it's just going over things we learned in 3.1. So identify each angle pair. So if we look at angle 1 and angle 3, what is the relationship between those two angles? Remember, on Friday we did corresponding angles, alternate interior angles, alternate exterior, and same side interior. So what would angle 1 and angle 3 be? Corresponding angles. Now let's look at angle 3 and angle 6. What would these two angles be? Alternate interior. Now let's look at angle 4 and angle 5. What would those two be? Alternate exterior. And lastly, we have angle 6 and angle 7. Same side interior. So the objective of 3.2 is to prove and use theorems about the angles formed by parallel lines and a transversal. So in this case, we are going to have two parallel lines. Remember, we can tell that they're parallel because they have that little arrow that shows that they're parallel. And then they're going to be cut by a transversal. So this is our first postulate, corresponding angles postulate. If two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. So in this case, what would be the relationship of angle 6 and angle 3? They're on opposite sides of the transversal and they're on the interior, right? So they would be alternate interior. So alternate interior angles are going to be congruent. What's the relationship between 1 and 6? Starts with a V. They're vertical angles. And we proved in chapter 1 that vertical angles are congruent. So what is the vertical angle to 3? 8. So all of the red angles are going to be congruent to each other. And we're going to go over examples on the next page. And then we have angle 5. What's angle 5's vertical angle? 2. What's the relationship between 2 and 7? Alternate interior. And then what's 7's vertical angle? 4. So we know that all of the blue angles are going to be congruent to each other and all the red angles are congruent to each other. So remember that postulates are statements that are accepted without proof. Since the corresponding angles postulate is given as a postulate, it can be used to prove the next 3 theorems. So theorem 3.1 is the alternate interior theorem. If two parallel lines are cut by a transversal, so we have two parallel lines, and they're cut by a transversal, then each of the alternate interior angles is congruent. So we would have this alternate interior angle is congruent to this one. And also we would have this alternate interior angle is congruent to this one. So alternate interior angles are congruent. Now let's skip to 3.3, the third one. Alternate exterior angle theorem. If two parallel lines are cut by a transversal, then each pair of alternate exterior angles is congruent. So we'll have this exterior angle is congruent to this one. Yes. And this exterior angle is congruent to this one. So alternate exterior angles are congruent as well. Now we have the consecutive interior angle. If two parallel lines are cut by a transversal, then each pair of consecutive interior angles is supplementary. In the last section, we know that consecutive interior angles are same side interior. They just gave it a different word here. So these are same side interior. So same side interior would be this angle and this one, the two with the stars. And these are supplementary angles. So same side interior angles are supplementary. What does it mean to be supplementary?
Equal to 180.
They add up to 180. So find each angle measure. So find the measure of angle ECF. So we have ECF. How would we find this angle?
Find out what angle DCE is. And then subtract that from 180.
We could do that. What's another thing we could do?
Since D is 5x, B would be also 5x, and then it would be 5x, and then it would be 180. So then the other side, that's C. Yeah, forget it.
No, wait.
You divide 180 by 5.
Since you write angle CBG is congruent with is the same thing? No.
Well, so CBG, what's the vertical angle to CBG? This one?
Yeah. No.
So what would the vertical angle to CBG, what's the measure of that one?
70.
70. So then what's the relationship between this angle and this angle?
They're the same.
Why are they the same?
They're alternate exterior.
Alternate exterior angles. So what would the measure of angle ECF be?
70 degrees.
70 degrees. Now let's find the measure of angle DCE. So you have DCE. What can we do to find this measure? Yes.
Well, since it's 70 and it has to equal 180, you just do 180 minus 70. And then when that equals 110.
Yeah. So we know that this one's 70. Why do we know that this whole thing is 180?
Because it's straight.
So, because they're a linear pair. So 5x plus 70 is equal to 180. So we can solve for x, or we know that 5x, so this angle is going to be 180 minus 70, so we know what Ryan said, it's just 110. But we can solve for x this way by subtracting 70 on both sides. So we get 5x is equal to 110, and then divide by 5. So x is equal to 22. If we could plug this one back in, so we get the measure of angle CDE, DCE is equal to 110. Any questions on this one?
Wait, why did you do all that if you knew it was 110?
If it asks us for x, if it says find x, then we need to do the math. But we could just look at it and say that since this whole line is 180, we could just subtract 70, and we know that this is going to be 110. So you could just do that. But if the question asked us to find x, we would need to do all the math.
Okay. So the question asks for x and 22 is your answer.
Yep.
And if it doesn't, then it's 110.
Yep. If it just asks, like this one, just asks for the measure of the angle, so it would be 110. So find the measure of angle QRS. So we have angle QRS. What would we do to find the measure of this angle? Yes.
So we know x and 118 are the same thing because of their corresponding.
So x would be 118.
So then 118 minus 180.
So we'd do 180 minus 118. And that would give us 62. So this angle here, QRS, would be 62 degrees. Good job. If a transversal is perpendicular to two parallel lines, all 8 angles are congruent. So if we had two parallel lines and a transversal that's perpendicular, what does it mean to be perpendicular? To intersect at a 90-degree angle. So if this intersects at a 90-degree angle, what do we know about this angle here?
That is a 90-degree angle.
That it's also 90 degrees because they form a linear pair. What do we know about this angle here?
90 degrees.
That it's also 90 degrees. What do we know about this angle down here?
90.
Why is it also 90?
Look at it, the alternate interior, and it also intersects at a 90.
Because it's alternate interior, so these two are going to be congruent, and it also intersects at 90 degrees. So all of these angles would be 90 degrees, so all 8 of them are congruent. Find each angle measure. So find the measure of angle EDG. So we have angle EDG. How would we find this angle? It wouldn't be equal to 180. It's equal to 75. Why is it equal to 75? Alternate exterior angles are congruent. So what's the measure of angle EDG?
75.
75. Now let's find the measure of BDG. So BDG. What would we do to find this angle?
Minus 180.
So know that this one's 75, so we would do 180 minus 75. And we would get 105. So the measure of angle BDG is equal to 105 degrees. Find the measure of angle ABD. So we have angle ABD. This number is talking about this angle, and this one's talking about this one. So what would be the formula we set up for this?
2x plus 10 equals 100.
2x plus 10 not equal to 180. What do we know that 2x plus 10 is equal to in this problem?
3x.
3x minus 15, because these are alternate interior angles, and alternate interior angles are equal to each other. So 2x plus 10 is equal to 3x minus 15. So now we solve for x. We can subtract 2 from both sides, 2x. So we get 10 is equal to x minus 15. We can add 15 to both sides. So we get 25 is equal to x. So this gave us x, but the question's asking us for angle ABD. So what do we need to do? So we plug it in to angle ABD. So we would have 2 times 25 plus 10, which is equal to 60. So the measure of angle ABD is equal to 60 degrees. Last slide. Yay. So, state the theorem or postulate that is related to the measure of the angles in each pair. Then find the unknown angle measures. So if we have angle 1 and angle 2, what is the relationship between these two angles? Alternate exterior. And what do we know about alternate exterior angles? They're congruent. So how would we set up this equation? They're equal to each other. But if angle 1 is equal to 120, then what would angle 2 be equal to? 120 also. So we just know this is 120. Now let's look at angle 2 and angle 3. What is the relationship between these two angles? Corresponding angles. And what do we know about corresponding angles? They're congruent. So how would we set up this problem? What would this equation look like? 75x minus 30
equals 30x plus 60.
is equal to 30x plus 60. So now we solve for x. What would be the first thing we do in solving for x, Ryan?
We subtract 30x from 75.
So we subtract 30x on both sides. So we get 45x minus 30 is equal to 60. Christian, what do we do next?
You add 30.
So So we add 30. So we have 45x. The 30s cancel. Is equal to 90. Robbie, what do we do next? Divide it by 45. So Ton, what do we get for x?
Maybe 2.
So x is equal to 2. So Nicole, what do we do next? We're trying to find angle 2 and angle 3. So we plug it in. So we take x is equal to 2 and plug it in. So it's 75 times 2. 150 minus 30.
120.
120. So angle 2 would be 120. And what's 30 times 2?
60.
60 plus 60?
120.
120. So both of these would be equal to 120. Yep, we said in the beginning that they were congruent. So now that we got that they're congruent, we know that. They just double checked our work. Now let's look at angle 3 and angle 4.
If you knew that, 2 is 120 from the last one, couldn't you just like put that?
What's the relationship between 3 and 4? Yes.
Alternate interior.
Alternate interior angles. And what do we know about alternate interior angles? They're congruent. So what would the equation look like for number 3? We set them equal. So we have 50x plus 20 is equal to 100x minus 80. So Nicole, what's the first thing we do when we solve for x? Subtract what? So we can subtract 20 from both sides. So we get 50x is equal to 100x minus 100.
Can you do plus 80 so you don't have a negative congruent?
We could. So you could do plus 80 on both sides. So that way we're not dealing with a negative. So we have 50x plus 100 is equal to 100x. So we subtract 50 from both sides. 50x, so we get 100 is equal to 50x. Ariana, what do we do next? We're solving for x.
You divide 50 on both sides.
So we divide 50 on both sides. And what do we get for x?
50. No, wait, 2.
You get 2.
2. X is equal to 2. So now what do we do with that 2?
You plug it in.
We plug it in. So we take x is equal to 2 and plug it in to both of these. So what is 50 times 2
100.
plus 20?
120.
So 120. And what's 100 times 2?
200.
Minus 80.
100.
So we get 120 for both of these. Which we know we did our math right because in the beginning we said that they were going to be congruent. Yes.
If like on the test, can we put like, since we know that 2 is 120 and then we know that 3 is 120,